Our next mesh entry is convex hull. This is a term that doesn't really give us a clue as to the purpose of this operation. In fact, a convex hull is the minimum shape that can enclose a set of vertices without creating any concave areas. Imagine wrapping a thin sheet of stretchy rubber around an object. The shape that this creates is our convex hull. Here we can see the result of creating a convex hull around Suzanne. Note that the faces of a convex hull are all tris by default. The obvious next question is, why would we want to do this? In fact, the convex hull shape is often used as a substitute for an object's true shape in video games when determining if objects have collided. The simpler shape of a convex hull makes the mathematics involved in that detection much simpler and hence faster. Of course, this approach is not as accurate as using the original shapes, but usually the convex hull is good enough to create a result that looks realistic enough for a game. Blender itself makes use of the convex hull shape when simulating the physics of the real world to create realistic collisions. Here we can see a small torus falling onto Suzanne. At first glance, it may look like the torus has hit Suzanne and bounced off. But if we take a closer look, we can see that the torus is deflected before it actually hits the monkey head. Now, if we display the convex hull used by Blender around Suzanne, we can see that the torus changes direction when it hits that convex hull. We'll be covering Blender's physics options in a series of later videos. When we apply the convex hull operation to a mesh, the last op panel offers us many further options. Delete unused. When selected, this deletes all previously selected elements in the mesh that were not used in the creation of the convex hull. We can see the result of using this option by turning on X-ray mode. All the internal elements of Suzanne are deleted when this option is activated. Use existing faces. Where faces of the original mesh are in the same location as those created by the convex hull, the original faces are used. The end result is that some faces on the convex hull may be quads or n-gons rather than tris. Make holes. This deletes any faces in the convex hull that were part of the original mesh. Join triangles. This joins adjacent tris into quads as long as the result is a flat plane. What tris are merged depends on the next three settings. Unfortunately, the difference between max face angle and max shape angle isn't well documented in the Blender manual, but both values affect which tris can be merged when forming quads, as we can see here as we adjust each in turn to affect the convex hull formed around Suzanne. Topology influence sets the degree to which Blender prioritizes the merging of faces to match existing topology within the mesh. In other words, it's a try it and see what results you get. Next, we come to a group of checkboxes. All but the last of these, when selected, restricts merging when a specific condition is met. Compare UVs prevents merging of faces that are not adjacent in the UV map used when applying textures. Compare color attributes prevents merging of faces when color values differ. Compare seam prevents merging of faces that share an edge marked as a seam. Compare sharp prevents merging of faces that share an edge marked as sharp. Compare materials prevents merging of faces that have been assigned different materials. Deselect joined deselects those faces that have been created by the merging process. Although the primary purpose of convex hull is to handle collisions, those are created automatically by Blender and remain invisible. So why do we have it as an option in the mesh menu? The answer is that, rather than use it for collision detection, we can also make use of it to quickly create shapes that might otherwise take us some time to produce. For example, Using a UV sphere and a circle, we can use convex hull to create a cone with a rounded top.